Mhm. All right. So 10.2, we're gonna evaluate and graph exponential functions. I don't think we get to graph them, but it says, okay. Exponential functions, okay. We're going to start with the equality property of exponents. Equality property of exponents. Mhm. So the equality property says that if b is greater than 0 and b is not equal to 1, here it is, then b to the x power is equal to b to the y power. If this happens if x is equal to y. There we go. Let's do an example. Let us use this property in an example. So 2 to the x power is equal to 16, for example. Now, from here we can see that what? That just by looking at it, we can see that x needs to be 4, right? Because if I do 2 to the 4th power, I get 16. But we're going to use the property to show that. So here's the property. We have it here. Then the next step will be 2 to the 4th power is equal to what? 16 can be expressed as 2 to the 4th power. So that's why we say that x is equal to 4. The two numbers are in the same base. Right here, we have the same base. The exponents are the same. So it may have been very obvious that x is equal to 4, but that's not every case, okay? So not every example is going to be as this one. So let me give you a different one. There we go. So now it's not so obvious, right? What power we must raise 8 to give us a 16. It's not going to be 2 because 8 times 8 is 64. So it's not that obvious anymore. So what we need to do first is we need to rewrite the left hand side, this side, and the right hand side with common bases. So let me write that down. Rewrite the left hand side and the right hand side with common base. That's what we need to do first, okay? So in order to do that, we're gonna do 2 to the third power would be 8, right? Now let's get the x there. And the 16, we know we could do 2 to the fourth power. Now they look like this, 2. Remember power to a power, you just multiply. So right here, we're going to apply the power rule. We just applied this one. And what does the rule says? Same base, the exponent are, the exponents are the same, okay? So 3x is equal to 4. And we are applying what we call the equality property. And from here, we get that x is equal to 4 over 3. So now, let's go back to we're doing the equality property of exponents. When b is greater than 0 and b cannot be equal to 1, same base, the exponents are the same. This example was easy because we know 2 to the fourth power will get 16. But in this one, we cannot do to the second power. So we rewrite the left and the right side with common bases. We just apply the power rule, power to a power. Right here, we have the same base, so we are applying the equality property. So x is equal to 4 over 3. Now, let's go back. So we have 8 equal to what? To 4 over 3. Hold on. Right? So what is 4 over 3? Remember that this one is the index and the numerator is the exponent. This is the index and this one is the exponent. So let's do it. What's this cubic root of 8? We know it's 2 to the fourth power. And what is 2 to the fourth power? 16. We got 16 here. Okay. Now, oops. Let's do some exercises. let's practice that. So this comes from 10.2 activity 1, okay? Let's do this one. Don't forget that we are applying the equality property of exponents. That's what we're applying here. Okay, so now I need to have 125 and 25 with the base of 5. So let's do 5 to the third power, right? 5 times 5. And 25 will be to the second power. So I rewrite the left side and the right side with a common base. Now I'm going to apply what? The power rule. This is equal to 5 to the power of 3x, and this is equal to 5 to the power of 2 times x minus 2. Have the same base now, right? So applied the equality property. 3x is equal to 2 times x minus 2. Let me distribute this. X is equal to -4. So we can check this in the calculator. Let me try that. 125. -4, so it would be 25, -6, right? Yep, I get the same thing. Look how I check it in the calculator. I just did the 125 to the power of what? -4. So I get 0.0004. And when I do the other one, 25 to the power of -6, I get the same number. Now, this is the same. For example, this one. Same base, right away we know it's 2, right? To the second power. 2 times 2. And this one will be 2 times to the third power. We apply the next step will be, we know that if we multiply power rule, we apply the power rule will be what? 2 times x plus 3 and this one will be 3x. Now, the equality property. So this is 2x plus 6. So what do we get here when I do this? I subtract it, and x is going to be equal to 6. 6 plus 3 is 9. So 4 to the 9th power is 26, 21, 44. And 8 to the 6th power, 26, 21, 44. So it's exactly the same. Okay, let me see another one. It's just finding the same base. That's what it is. Nothing else. I don't see anything else that look at this one. 4 3x minus 7 equals to 32 2x. Okay, so our job is to what? Rewrite, right? With a common base, the left side and the right side. So 2 times 2 to the second power would be 4, right? And 2 times 2 to the fifth power would be 32. Apply the power rule, what do we get? Power to a power. This is 10x. Now we applied the rule that we're talking about. This will be equal if the exponents are the same. So I'm going to distribute this 10x. Let me subtract that 6 on both sides, and what I get is 4x equals to negative 14. So x is equal to negative 14 over 4. And this is what? Negative 7 over 2. Okay. Now, look at this one. It's kind of different. Um, 1 over 27. So go ahead. So first, 1 over 27 is the same as 27 to negative 1 power. Now, let's get the same base on both sides. So that's going to be, get more little here. Hold on, I'm just getting more. Perfect. So this will be 3 to the what? To the third power. Now we have the same base. Power to a power. When I said that we have the same base, here is the 3. So negative 3 is equal to 2x. So x is equal to negative 3 over 2. It's just finding the base, the common base. Let me go really quick. Oops, no, it's not there. I'm gonna go into 10.2. Okay, let's do this one. I have one close to that one. Okay, so this is from Newton, and it says E they want us to solve this. All right, so the first, go ahead. The first part that we need to remember is the quotient property of exponents. And I'm going to write it down right here. It said that was equal to what? A m minus n, that we subtract the exponents. That's the quotient property of exponents. Okay, so based on that, we're going to have just one e here, and we're going to do x to the second power minus 99 equals to e to the 2x. Perfect, because now we have the same base. So x squared minus 99 is equal to 2x. So if I move this one to this side, I get x squared minus 2x minus 99 is equal to 0. And we're going to factor this. So it will be 40, no, 11. 99. So this one is going to be, when I subtract it, the 11 is going to be negative and the 9 is going to be positive. So what do I get from here? X equal to 11, and I get x equal to what? To negative 9. Let's go ahead and check the solutions. So we're going to check for x equals to 11. So let's go back to what we had there. So we have e, that's what we were given. 99 equals to e. Now, we're going to replace the x with the 11. So it will be 11 to the second power. And e, 90 to the 99, that will be 2 times 11. So 11 to the second power, that's going to be 121. And e to the 22. So let's subtract these two. I get the same one, e to the 22 and e to the 22. So that's fine. And if we do the other one, sorry, which is x equal to the negative 9. So it's going to be, this is what we have originally. Negative 2 times negative 9. 2 times negative 9 and 99. So this is going to be E18 and E negative 18. Oh, it's not 2 times. It's a square. So it's 81. There we go. When we subtract 81 minus 99, we get negative 18. So it's okay. It's the same. All of the other exercises from this 10.2, they're using the E. Do one more here that I just saw. It says solve, and we have this one. 1 equals to 36. Okay. So let's get the same base, right? 6. So it's just this one. 6 times 6, 36. Same base. We're going to apply the equality property. So the negative 3x minus 1 is equal to 2. We're going to add 1. So x is equal to what? To negative 1. And we could go back and check this into the equation. And what do we get? Negative 1 minus 1 equals to 36. So this is going to be negative 3. Oh no, this is plus. Sorry, this is plus minus 1. This is 2 positive. Mhm. Perfect. Equal to 36. Let me tell you, they were the same. So let's go. Um, this is the end of 10.2.